Thank you, Victoria. All right, so we're going to move into multiplying first. Now, all I want you to do when you see this is to think that you're multiplying binomials. All right, so if you think of this, and if you want to use what your middle school teacher told you about FOIL, that's fine, I don't care. All right, you multiply the first ones, right? So 3 times 4, boys listen, 3 times 4 is 12.
12.
Excellent. Then this 3 times the negative I, what's 3 times negative I? It's actually negative 3I, right? Because a positive 3 times a negative I is negative 3I.
I see what you did there.
So I'm multiplying this 3 times each of these terms. So 3 times 4 is 12. 3 times negative I is negative 3I. First, outside, inside, last. Now, the next one is take the 6I and multiply it times each of these terms. So, what? Yeah, that's an acronym that math teachers like to use. I don't, but that's what math teachers like to use. 6I times 4 is 24I. You can draw the arrows on your paper. And then 6I times negative I is negative 6I squared. So I don't draw arrows, Daniel. I did 3 times each of them. Then I did 6I times each of them.
And then do you combine like terms?
Let's combine the middle two terms. Dominic sees that these middle two terms are like terms. They both have the letter I. So what's negative 3I plus 24I?
21.
It's 21I. Very good.
But you always have to look at the front. You can't do like -1 times 6I and 3.
I mean, you can. It's just I don't want your brain to get confused about which ones you're doing. I would highly encourage you to start with the very first term and multiply it by each of the terms in the other binomial. Go to the second term, multiply by each of the terms in the other binomial. That's called distribution. Come on.
Does it matter if the 6I squared goes first? Like I squared plus 21I plus 12.
Well, I'm about to change the I squared, though. I think you have a good question, but if you look up here, just as a reminder from the first micro lecture, I squared is the same as -1. Exactly. So I'm not actually going to rewrite the I squared again. I'm going to write -6 times -1.
Oh, that's what you're talking about.
That's what I was trying to explain in the first lecture. We got a little sidetracked.
No, you said
So now it's here.
You did -1 because of the...
Because I squared is the same as -1.
Oh my bro.
Yes, Victoria H.
I squared with
Victoria H is exactly right. Anytime you see I squared, you should automatically replace it with -1. But make sure you use parentheses. All right, because you're going to notice, even though that's a -1, you have a -6 in front of it. So what's going to happen to all of this at the end?
It's just going to go to the 6.
It's going to become positive 6. So it's going to be 12 plus 21I
You combine those.
plus 6. So that's why, Camilla, I didn't really answer your question, because whenever you see I squared, it actually is a real number. All right? So now the 6 and the 12 can be added because they're both real numbers.
So are you going to use the number all the time, or I squared? Always going to be negative.
I squared, good question, Camilla. I squared will always be -1. You're probably going to have a different number in front of it, but I squared will always be -1. So the answer is 18 plus 21I. Yes, Fernando.
What did you get squared in the first line?
Okay, how did I get I squared? So on the last two terms that I multiplied 6I times -I. And that's -6I squared, because Sergio is right. I times I is I squared. Just like, Fernando, when you were in Algebra 1, you learned x times x is x squared. Okay, are there any questions on multiplying? Most students that mess this up, they mess up on the first part. They can't get the 4 terms when they multiply. They do something wrong in their distribution. If you get that right, the next opportunity to mess up is what to do with the I squared. Students mess up what to do with the I squared. So just be careful on those two steps, and you should be okay here. And this will be on the SAT.
For students.
Multiplying complex numbers will be on the SAT.
Maybe on the test?
Well, I mean, yeah, of course. Yes. I'm saying not only will it be on our test, but it's also on SAT, the test. Let's do division.
No.
Yes. Now, when we're doing this, please, you're not out until 11:30 and then you go to lunch. I want you guys to write small. If you run out of room, do you see how there's a blank area on your slides? You can use that area for extra work if you need it.
Oh, that was on
Okay.
purpose?
That was on purpose, yes.
There's no mistakes in that.
I'm just going to keep going. So, for division, stay with us, Camilla. For division, I just want you to think it's really just two multiplication problems. Okay? Does everyone feel confident about multiplication? You saw how we did it. So when we get to division, don't psych yourself out. It's really just two multiplications. That's all. Now, here's how we have to deal with this. Does everyone see in the denominator that we have the letter I? We can't have that from that lecture earlier. You know that I is the square root of -1. And you cannot have radicals in the denominator. That's from an Algebra 1 lesson you did with Miss Byrne or Miss Hunter. Okay? So we have to get rid of it. And here's how we're going to get rid of it. Do you guys remember the complex conjugates that we talked about in the first part of this class? You don't remember the conjugates? How you make the imaginary term the opposite? Look in the denominator. You have 4 minus 2i. What's the conjugate of 4 minus 2i? Very good. So you're going to multiply the numerator and the denominator. I didn't flip anything. All you do is you multiply the numerator and the denominator by the conjugate of the denominator. You'll see what happens. Okay, Victoria H. Okay, so do you see the denominator? Okay, what's the conjugate of 4 minus 2i? 4 plus 2i. So I'm going to multiply it to the top and the bottom, because otherwise I'd be changing the value of this expression. All right, so the first thing you see, Victoria H., when you see division of complex numbers, is to find the denominator and then multiply the numerator and the denominator by the conjugate of that denominator. Every time. Now, the reason I try to tell you that it was just 2 multiplications is because now you should see I'm going to do 2 multiplications. I'm going to multiply everything on the top and everything on the bottom. So I prefer to do the bottoms. I want to show you why we did this. It's not going to cross. There's no proportion here.
Oh, you're right. It's not the button.
There's no butterflies. Right. If there's butterflies, we should figure out why they're getting in. Okay. Does everyone see what I wrote here? I wrote down, well, I haven't finished it yet. So I wrote down the original denominator times its conjugate. That's on purpose. Well, let me show you why we do this. You ready? Okay. So follow along for how to distribute this. Actually, I'm going to have Nathan tell us how he's going to multiply. Nathan, how would you multiply? Go for it, Nathan. Excellent. What is 4 times 4? Awesome. Perfect. Good. Let's not mess it with Nathan. Okay? He's trying to help us out. Nathan, what's the next one you should multiply? 4 times 2i. Very good. Which is? 8i. Keep going. Slow it down. There's a sign in front of it. Which is? Very good. And the last one? Which is? No. Let him figure this out, please. Close, but 2 times 2 is... Guys, listen. Shh. Nathan, you got it. So it's going to be perfect, Nathan. Okay, let's pause here. Is everyone good on how Nathan got all of these terms? Thank you, Nathan, for your help. Everybody good? Now, your brain might already be seeing why we did this. Maybe your brain is understanding why we just multiplied the conjugate. Because if you look at these 2 middle terms, they become 0. the 8i and the negative 8i become 0. They're gone. So we have effectively eliminated our imaginary term in the denominator. Okay? But we still have to deal with that I squared. Right? So I'm going to write minus 4 times negative 1. Very good. So that's going to become 16 plus 4, which is 20. So what's going to be my new denominator?
2 plus 8.
Nope. What's going to be my new denominator?
Oh, 16.
20.
Oh, that's right.
All we did was found the denominator.
No.
You're fine.
Wait, that's so confusing. We have to do all of that.
Let me. What was confusing?
We also have to replace the.
We haven't done the numerator yet. All we've done is the denominator. That's the whole point so far.
But that's not the answer.
That's not the answer. This is going to be part of the answer.
Wait, so then what goes on top?
We'll get
Game
there.
there.
We got to do the top. Now, I just want to make sure we're all clear. Your brain should see why we just did that. Because now in the denominator, you should not see the letter I. Dominant.
So what if they don't cancel?
If you then you've done something wrong. Because every time you
So they should cancel out every time.
every time you multiply conjugates, you're going to get these have opposite signs. So they will always become 0. If you're not getting that, then something is wrong. Okay?
There's no such thing as like the thing that we used to call the old like impossible or whatever it was.
Imaginary?
Insolvable.
There's
No solution?
Yeah, no solution. There's not gonna be a problem like
no. You will always be able to find the answer for these. Yes. Now let's do the numerator.
A real
Why do we put the 20 where? Because all the work I just did, Fernando, was multiplying the denominators. That's all that work I did was just denominator work. Now we got to do the numerators. Guys, I can't hear Camilla if you're speaking. Here we go. Here comes the same work for the top. 2 plus 8i times 4 plus 2i. Yes, Maria? You're good. Here we go. Remember, back to our last micro lecture, we talked about conjugates. Conjugates are where you change the imaginary term to the other sign. So if this says 4 minus 2i, you're going to write here the conjugate, 4 plus 2i. And that will always be the case. If you put the conjugate here and multiply, right, straight across, you will always eliminate your imaginary term. Exactly. So you should, if you put this down here, it's got to be the same on top. And now we're doing the numerator. Okay, so I'm going to have, yep, come on.
So we always multiply by the denominator. Like how do I explain it?
You're fine.
Like take off another fraction and we just always do the denominator to divide the top.
Yes, so when I'm checking your work on the test, if I look at what you wrote here and it's not exactly the same, that's a problem. I think that's what your brain is asking? Yeah, it should be the same. Okay, I'm going to go with, let's go with David. David, can you multiply this out for us like Nathan did to give us the terms? So say which ones you're multiplying. Say which ones you're multiplying, please. Thank you. Do the next one. Please say the terms you're multiplying.
2 times 2,
Which is?
4i.
Keep going.
Plus 8i times 4.
Which is?
32i.
Okay, and the last one?
Plus 8i times 2i.
Which is?
16i.
Not I2. Thank you. I squared. Thank you, David. Now, you will notice here, all right, some of your brains might have already noticed this, but you notice here that these two imaginary terms are not going to make 0. Right? Because this is the numerator. The numerator can have an imaginary term. It's okay to have the letter I in the numerator, in the top. It's not okay to have the letter I in the bottom. So I'm going to go ahead and add those together and get 36i. Now, when I write I squared, you know I'm going to replace that with -1. So that's ultimately going to become 8 plus 36i minus 16. Because a positive 16 times a negative 1 becomes negative 16. Daniel, is there a problem? Is there a question? You made a lot of noises. Right. In the future, just make them internally, right? Yes, Nicholas. I squared will always be replaced with negative 1.
You can never just square it.
No, because ultimately the I to the second power just means to replace it with negative 1. So whenever you're doing these problems, Nicholas, and even on the SAT, I think they even say replace I squared as negative 1. They write it down. Okay? All right, now we're almost done. What's 8 minus 16?
8.
Good, Dominic. So negative 8 plus 36i. Now where is this going to go? In the numerator. And you have found the answer.
That's the answer?
No.
That's why I went.
You're not done yet. This is the answer. This is the answer, but it's not simplified. All right? Look at your 3 terms. Let me pull it up here so you can see. Do you see the negative 8, the 36, and the 20? All 3 of those numbers can be divided by the same number. 4, actually. You could use 2, but you have to do it again. 4 is the highest number that you can factor out. So you're going to get negative 2 plus 9i over 5. So you'd get almost full credit for this one. Almost full credit. Full credit is here. Now, my hope was that after doing that example, that you see that dividing these complex numbers is really just 2 multiplications. It's really just 2 multiplications. I'm so happy, Dominic. Are there any questions? Who is saying one more? Is that you, Sergio? We're not doing one more. You're going to do 6 more. Okay?